In the beginning there is no noise, no urgency, no sense of anything needing to happen. The Earth exists, but not as a storm of chaos as it is often imagined. Instead, it rests in a quiet balance, held together by something that cannot be seen, touched, or directly felt. This force is always present, yet almost never noticed. It does not announce itself, and because of that, it quietly disappears into the background of everything. Gravity is not something early life would have recognized. It is not something we recognize even now, at least not in the way we notice light, sound, or heat. And yet it is there, shaping every motion, guiding every fall, holding every ocean against the surface of the planet. If the early Earth could be observed from a distance, it might appear violent. Volcanoes would rise and collapse, oceans would churn, continents would shift slowly beneath a heavy sky. Everything visible would suggest instability, but beneath all of it there is something steady, something that does not flicker or break. It holds the chaos in place without ever becoming part of it. This is where the story begins to shift, because what feels constant may not have always been exactly the same. The Earth was still forming, still settling, still adjusting its own internal weight. Layers moved, materials separated, density changed over time, in ways too slow to notice in any single moment. And with every shift in mass, something else may have shifted as well. Not dramatically, not suddenly, but quietly, in the same way everything else on the planet was changing. It is easy to believe that gravity has always been what it is now. After all, it feels unchanging, reliable, almost permanent. But that sense of permanence comes from a very limited window of time. Human experience is brief, and within that briefness, gravity does not seem to vary. So it becomes something assumed, something unquestioned. Yet, the deeper the story goes, the less certain that assumption begins to feel. Because if everything else was changing, if the planet itself was still finding balance, then the force tied to that balance may not have been identical to what it is today. It may have been slightly stronger, or slightly weaker, or distributed in ways that no longer exist. The difference would not need to be large to matter. Even the smallest variation, acting continuously over millions of years, could shape outcomes in ways that are almost impossible to trace. And so the question begins to form, not loudly, but in a quiet, persistent way. What if the most powerful force shaping life on Earth was the one no living thing could ever see, or even think to question? What if it changed, just enough to matter, long before anything existed that could remember it? The idea does not arrive as a conclusion. It lingers almost unnoticed, like the force itself. And as it settles into awareness, the stillness at the beginning of the story no longer feels quite the same. There is now a subtle tension beneath it, a sense that something familiar may not be as fixed as it appears. The ground feels steady, the oceans feel contained, the sky feels distant and unchanged. Yet all of it depends on something that has never been directly seen. And if that unseen force could shift even slightly, then the entire story of the planet begins to open in a new direction, not as a contradiction of what is known, but as a quiet expansion of what might be possible. And with that possibility, the story moves forward, slowly, carefully, toward a deeper question that has been waiting beneath everything from the very beginning. If gravity was always present, could it have ever been different? Or has something quietly changed without leaving a clear trace for us to see today at all in the beginning? The planet did not yet feel complete. It existed as a gathering of matter, a slow accumulation of fragments drawn together through endless motion. Pieces collided, merged and settled, not in a single moment but across stretches of time too vast to fully imagine. Nothing about this early Earth was finished. It was forming, adjusting, redistributing its own substance, as if searching for balance it had not yet found. The surface shifted, the interior churned, and every movement carried with it a quiet consequence that would shape what the planet would eventually become over long, silent ages. It is often imagined that the early Earth was defined only by violence, by fire and impact and instability. And in many ways, that is true. Yet beneath that visible unrest, something quieter was unfolding at the same time. As materials sank or rose depending on their density, the planet began separating into layers, each finding its place within a larger structure. Heavier elements moved inward, lighter ones drifted upward, And through this slow rearrangement, the Earth began to define its internal shape. This process did not happen instantly, and it did not happen evenly everywhere across the forming surface. As the internal structure changed, the distribution of mass across the planet was never completely settled. It shifted gradually, sometimes subtly, sometimes in ways that reshaped entire regions. Continents had not yet taken their modern forms, and oceans were still defining their boundaries. Everything was in motion, even if that motion was too slow to witness directly, and with every change in how mass was arranged, there came a quiet implication that is rarely considered. Gravity is not an independent force standing apart from the planet. It is tied to it, shaped by it, and responsive to its structure entirely. This idea begins to change the way the Earth is understood. If gravity depends on mass and distribution, then a planet still reorganizing itself would not produce a perfectly uniform or unchanging pull. The differences may have been small, almost impossible to detect without modern tools, yet they would have been present. Slight variations in density deep within the planet could influence how strongly different regions experience that pull. Not enough to break the world apart, not enough to create obvious disruptions, but enough to shape how materials settled and how environments formed over time in quiet, persistent ways. It becomes clear slowly that gravity is not simply a number that remains fixed regardless of circumstance. It is part of the system connected to everything the planet is, and everything it is becoming. As the Earth continued to cool, to separate, to stabilize its inner layers, the force it generated would have followed those changes. Not dramatically, not in ways that would leave obvious marks, but in subtle shifts that unfolded alongside the planet itself. The balance we experience today may be the result of a long process that had not yet reached completion in those earliest ages fully. And within that unfinished balance, something else was beginning to take shape. The conditions that would eventually allow life to emerge were forming slowly, influenced by countless factors working together. Temperature, chemistry, pressure, and movement all played their roles. Yet beneath them, guiding them in ways that were never directly seen, was the steady influence of gravity as it existed at that time. If that influence was even slightly different, then the foundation upon which life would arise was also different, even if the difference left no clear trace behind. It may have guided outcomes in ways we cannot reconstruct. Before life began, before anything existed that could sense or respond, the ground beneath it was not as steady as it might seem when viewed from the present. The planet was still settling into itself, still defining the balance that would one day feel permanent. And if the balance was still being found, then the force holding everything together could not have been entirely stable either. It would have shifted with the planet quietly, continuously, shaping the stage upon which everything else would unfold, leading inevitably toward a deeper question about what gravity depends on and what defines its nature. There are certain ideas that feel so stable, so reliable, that they are rarely questioned. They sit quietly beneath everything else, forming a foundation that seems beyond doubt. Gravity is one of those ideas. It is taught as a constant, described as unchanging, and accepted without hesitation. It pulls downward with the same quiet certainty, day after day, moment after moment. Nothing about it appears uncertain, and because of that, it becomes something we stop thinking about altogether in our daily lives. But the word constant carries an assumption. It suggests something fixed, something that does not shift, something that exists independently of everything around it. And yet, when looked at more closely, gravity is not isolated in that way. It is not a separate entity acting from outside the system. It is part of the system itself, shaped by the mass of the planet, the distance between objects and the way that mass is arranged. It does not exist without these conditions. It emerges from them, responds to them, and changes with them, even if those changes are almost impossible to notice directly. This is where the definition begins to feel more fragile than it first appears, because if gravity depends on mass and distribution, then any change in those factors, no matter how small, has the potential to alter how gravity is experienced. The early Earth was not static. Its interior shifted, its surface reformed, and its mass was redistributed over time. Each of these changes, even when subtle, would have influenced the balance of forces across the planet, not in a way that would cause immediate disruption, but in a way that would quietly adjust the conditions under which everything else existed. These adjustments would not have been dramatic. There would have been no moment where gravity suddenly changed in a way that could be clearly observed. Instead, the differences would have unfolded gradually over immense stretches of time. So gradual, in fact, that no single moment would reveal them. They would blend into the background, becoming part of the natural state of the world as it was experienced at that time. And because there was nothing to compare them to, nothing to measure them against, they would have gone completely unnoticed. This creates a kind of hidden uncertainty. Something fundamental may have been shifting, not in a way that left obvious marks, but in a way that influenced everything built upon it. The surface of the planet, the movement of oceans, the settling of materials, all of it would have been guided by this force as it existed in that moment. And if that force was even slightly different, then the outcomes it shaped would also be different, even if those differences are difficult to recognize now. What if constant was never truly constant, but only appeared that way from the narrow perspective of the present? What if the stability we feel is not a permanent state, but the result of a long process that has already unfolded, beyond our ability to observe it directly? These questions do not arrive as contradictions, but as quiet expansions of what might be possible, and within that possibility, a deeper realization begins to take form. If gravity was even slightly different in the distant past, then everything that depended on it, from the smallest interactions to the largest structures, developed under conditions that no longer exist in quite the same way. The difference may be subtle, almost invisible, but it would be woven into the fabric of everything that followed. With that thought, the idea of gravity begins to shift from something fixed to something more dynamic, more connected, more uncertain than it first appeared. And as that uncertainty settles in, the story moves forward into a new and more delicate question, one that reaches beyond the planet itself and into the origins of life. If such an invisible force could change even slightly, then how might those changes have shaped something as fragile and complex as life in its earliest beginnings? The story moves quietly into the oceans, where life is believed to have begun. There are no large forms yet, no movement that can be easily seen, no creatures that can be named or recognized. Instead, there is only water filled with particles drifting slowly through a world that feels calm on the surface, but is constantly changing beneath. Chemical reactions unfold without intention, guided by conditions that seem simple at first, yet are shaped by forces that remain hidden from view. It is within this quiet, almost invisible activity that something remarkable begins to take form over time. The earliest cells do not appear suddenly. They emerge through gradual organization, as molecules come together separate and come together again in patterns that become increasingly stable. These interactions are delicate. They depend on proximity, on timing, on the way particles move through their environment. Nothing about this process is guaranteed. It requires a balance that is maintained not through control, but through the constant influence of surrounding conditions that shape every movement in subtle ways. At this scale, it is easy to imagine that gravity plays no role at all. The particles are so small, their motion so dominated by currents and collisions, that gravity seems almost irrelevant. But it is still there, quietly influencing how things settle, how they drift, how they remain suspended or come to rest. It does not act strongly, but it does not need to. Even a gentle influence applied continuously can shape outcomes over time, especially in a system where everything depends on small differences and fragile arrangements. The early oceans were not still. They moved slowly, carried by temperature differences, chemical gradients, and the shifting structure of the planet itself. Within these movements, particles were constantly repositioned. Some sank slightly faster, some remained suspended a little longer, some clustered together in ways that would not have occurred under different conditions. These differences were subtle, almost impossible to detect directly, yet they influenced how molecules encountered each other and how often those encounters led to something more stable. And this is where the idea begins to deepen. If gravity was even slightly different during this time, then the way particles moved through these early oceans would also be different. The rate at which molecules settled, the way clusters formed, the stability of certain arrangements, all of it could shift in response to even the smallest variation. The difference would not need to be dramatic. It would only need to be consistent, shaping interactions moment after moment, over spans of time far beyond human comprehension. This leads to a realization that feels both subtle and profound. The first living cells may not have formed under the same conditions that exist today. The balance that allowed them to emerge may have depended on factors that no longer exist in quite the same way. And because these differences were so small, so deeply embedded in the process itself, they would leave no clear trace behind. There would be no marker, no boundary, nothing to indicate that the conditions had once been different. What if life began in a world where the rules were slightly altered, not enough to be obvious, but enough to matter? What if the very first steps toward life were guided by conditions that have since shifted beyond recognition? The thought does not disrupt what is known, but it adds a layer of uncertainty that changes how that knowledge is understood. And if something as delicate as the formation of the first cells could be influenced by such subtle forces, then the implications extend further. Because once life begins, it does not remain small. It grows, it adapts, it becomes more complex. And in doing so, it carries with it the imprint of the conditions in which it first emerged, leading to a deeper question about what traces those early influences may have left behind. As life continued, it did not remain confined to the microscopic. Over long stretches of time, simple cells began to gather, to cooperate, to form structures that were no longer defined by a single boundary. These early multicellular organisms did not appear with intention. They emerged slowly, shaped by the same quiet conditions that guided the first cells. And as their forms became more complex, something else became more important as well. Structure began to matter. Shape, density, balance, and movement were no longer abstract ideas. They became part of survival. Every body, no matter how simple, must exist within the limits of the world around it. It must hold itself together, resist collapse, and interact with its environment in a way that allows it to continue. Gravity, though rarely noticed, becomes part of this balance. It influences how a body supports itself, how it grows upward or outward, how it moves through water or settles against the surface beneath it. It defines limits, even when those limits are not clearly seen. If gravity is stronger, structures must be more compact, more resistant to collapse. If it is weaker, forms can extend further, becoming larger or more delicate without breaking under their own weight. These are not dramatic differences. They are subtle adjustments, shaping what is possible and what is not, guiding the direction of growth without ever being directly observed. When looking at early life forms preserved in the fossil record, there is often a sense of unfamiliarity. Some shapes appear unusual, almost as if they do not follow the same rules as modern organisms. Their structures seem fragile, their proportions unexpected, their forms difficult to compare to anything that exists today. These differences are often explained as early experiments in evolution, variations that did not persist as life continued to change. But there is another way to look at them, one that does not contradict what is known, but expands how it might be understood. What if these forms were not strange at all within the conditions in which they existed? What if they were perfectly suited to a world where the forces acting upon them were slightly different from those we experience now? The possibility does not require a large shift. Even a small variation in gravity could influence how bodies develop. It could allow certain structures to exist that would not be stable under present conditions. It could change how organisms move, how they anchor themselves, how they distribute their mass. Over time, these differences would become part of the natural form of life, not something unusual, but something expected within that environment. Movement itself would also be affected in water. Where many early organisms lived, gravity influences how buoyancy and resistance interact. A slight change could alter how easily an organism rises or sinks, how it drifts or stabilizes, how it expends energy to maintain its position. These differences, though subtle, would shape behavior and structure together, creating forms that reflect the conditions around them in ways that are not immediately obvious. This leads to a quiet but powerful realization. The fossil record may not only tell the story of biological change, but also the story of the environment in which that change occurred. And if that environment included even slight variations in gravity, then those variations may be embedded within the forms we observe, hidden within their structure and balance. What if the shapes of ancient life were not strange at all, but simply unfamiliar because they belong to conditions we no longer experience? What if what appears unusual is only unusual from the perspective of the present? The idea does not demand certainty. It lingers as a possibility, one that shifts how the past is viewed without rewriting it entirely. And as that possibility settles in, it opens the way for a deeper question. If life itself may carry traces of these unseen differences, then the world around it, the environment that shaped it, may hold even more subtle signs of a force that was never truly constant. The oceans arrive quietly in the story, not as empty stretches of water, but as the place where everything begins to connect. They cover the surface of the early Earth, deep and wide, holding within them the conditions that allow life to continue its slow unfolding. From above, they might appear calm, reflecting a dim sky that has not yet settled into the patterns we know today. But beneath that surface, there is constant movement. Water shifts, circulates, and carries with it countless particles, each following paths that are shaped by forces too subtle to notice directly. The ocean is never still. It breathes in slow currents, rising and sinking, layering itself in ways that are guided by temperature, chemistry, and pressure. And through all of this, gravity is present, influencing how water moves, how materials settle, how layers form and remain stable. It does not act loudly. It does not interrupt the flow. Instead, it defines the direction of every movement, quietly guiding what sinks and what remains suspended. In this early world, the oceans are not yet familiar. Their chemistry is different, their temperature uncertain, their structure still forming. Particles drift through them in endless motion. Some sink toward the depths, others remain suspended for longer periods, and some gather into clusters that move together through the water. These patterns are not random. They are shaped by the balance of forces acting at every moment, including the steady pull that draws everything downward. Even the smallest difference in that pull could change how the ocean behaves. If gravity were slightly stronger, particles would settle more quickly, layers would form more sharply, and the movement of nutrients might become more restricted. If it were slightly weaker, materials could remain suspended longer, currents might carry them further, and interactions between particles could occur in different ways. These are not dramatic changes. They are quiet adjustments, shaping the environment continuously without leaving obvious signs behind. And yet, those quiet adjustments matter. Life depends on access to energy, to nutrients, to the right conditions at the right time. The way these elements move through the ocean determines where life can emerge, where it can grow, and where it can survive. If the movement of the ocean is even slightly altered, then the pathways available to life are also altered. The difference may not be visible, but it becomes part of the foundation upon which everything else is built. The ancient oceans may have moved to a rhythm shaped by a force we never thought to question. Not a rhythm that could be heard or measured directly, but one that influenced the timing and distribution of everything within them. Currents may have been slower or faster in subtle ways, layers more or less stable, particles drifting along paths that no longer exist in quite the same form. These differences would not stand out. They would blend into the natural state of the world at that time, shaping conditions without ever drawing attention to themselves. This creates a sense of something just beyond reach. The oceans carried everything: energy, materials, the earliest forms of life, and in doing so they also carried the influence of gravity as it existed. Then, if that influence was even slightly different, then the entire system moved differently, even if no clear trace remains to show it. And so, the question begins to deepen. If gravity influenced not only life, but also the environment that supported it, then could those influences still be hidden within the patterns we observe today? Could the way sediments settled, the way layers formed, the way fossils are preserved, all carry subtle signs of conditions that no longer exist? The oceans settle into memory, their movements fading into the distance, but the questions they leave behind do not disappear. Instead, they lead forward quietly toward the next part of the story, where the search begins for evidence that may still exist, waiting to be noticed within the world we thought we already understood. The story returns to land, but not to a world that can be seen directly. Instead, it arrives through fragments, shapes preserved in stone, impressions left behind by life that no longer exists. Fossils are often treated as clear records, fixed snapshots of the past that can be studied, measured, and placed into a timeline. They feel reliable, almost certain, as if they are telling a story that has already been fully understood. And yet, when looked at closely, some of these shapes do not settle easily into what we expect them to be. There are forms that seem too delicate for their size, structures that extend further than modern organisms would allow, bodies that appear unbalanced or inefficient when compared to what exists today. These differences are not always dramatic, but they are noticeable enough to raise quiet questions. Why would life take on shapes that seem so fragile, so unusual, so difficult to sustain under the conditions we know now? The usual answer is that early life was experimental. Evolution had not yet refined its designs, and so it produced a wide range of forms, some of which did not persist. This explanation is not incorrect. It fits within what is understood about how life changes over time. But it also rests on an assumption that is rarely examined. It assumes that the physical conditions shaping those forms were the same as they are today. What if that assumption is not entirely complete? Every structure is shaped by the forces acting upon it. A body must support its own weight, resist collapse, and function within the limits of its environment. If those forces are constant, then the limits they create are also constant. But if those forces shift even slightly, then the boundaries of what is possible shift as well. A form that seems fragile under one set of conditions may be perfectly stable under another. When these early fossils are viewed through that lens, something begins to change. The shapes that once appeared unusual no longer seem inefficient. Instead, they begin to look like solutions, forms that made sense within the world in which they existed. Structures that seemed too extended may have been supported by conditions that reduced the stress acting upon them. Bodies that appear unbalanced may have been moving within environments where balance was defined differently. This does not mean that the fossils are being misunderstood. It means that the context in which they are interpreted may be incomplete. The assumption of constant gravity provides a stable framework, one that allows for clear analysis and comparison. But if that framework is slightly different from the conditions that existed at the time, then the conclusions drawn from it may also carry that difference. The tension here is subtle, but it grows as the idea settles in. The fossils themselves do not change. They remain exactly as they are, preserved in stone, holding their shapes across immense spans of time. What begins to shift is the way they are seen, not as anomalies or failed experiments, but as evidence of a world that may have operated under slightly different rules. What if the strangest fossils are not mysteries of evolution at all, but quiet clues pointing toward conditions that no longer exist? What if they are not out of place, but simply out of context when viewed from the present? The thought does not demand certainty. It lingers as a possibility, one that invites a deeper look rather than a quick conclusion. And as that possibility takes hold, the focus begins to widen, because fossils do not exist alone. They are part of a larger record, surrounded by layers of rock that formed under the same conditions. If the shapes of life carry subtle hints of a different world, then the ground that preserved them may hold even deeper signs, hidden within patterns that have always been there, waiting to be seen in a new way. The story deepens, moving away from the shapes of life and into the ground that holds them. Beneath every fossil, beneath every preserved form, there are layers of rock that have been forming long before and long after life left its imprint. These layers are often treated as passive records, quiet backgrounds that simply contain the evidence we seek. But they are not passive at all. They are shaped slowly and continuously by the same forces that shaped everything else. Sediment does not arrange itself randomly. Each grain, each particle settles according to the conditions around it. It falls through water, drifts through currents, and eventually comes to rest in a position defined by balance. Gravity plays a central role in this process. It determines how quickly particles sink, how tightly they pack together, and how layers form over time. The structure of rock is not just a result of what materials are present, but how those materials were guided into place. At first, the process appears simple. Particles settle, layers build, pressure increases, and over time, sediment becomes stone. But when looked at more closely, the process reveals a complexity that is easy to overlook. The rate at which particles settle can vary. The way they align can shift. The density of layers can change depending on how pressure is applied over long periods. Each of these details is influenced by the conditions present at the time, including the steady pull that guides everything downward. If gravity was slightly different, even by a small amount, the effects would not be obvious at first glance. There would be no sudden break in the layers, no clear marker separating one condition from another. Instead, the differences would be subtle. Sediments might settle a little faster or a little slower. Layers might be slightly more compact or slightly more dispersed. Over time, these small differences would accumulate, creating patterns that are almost but not quite what would be expected under present conditions. This is where the sense of quiet intrigue begins to grow. Some geological formations appear straightforward, aligning neatly with what is understood about how rocks form, but others contain details that feel slightly out of place. Layers that are thinner or thicker than expected, structures that seem to have formed under conditions that are not easily explained, patterns that suggest a different balance of forces at work. These inconsistencies are not dramatic. They do not stand out as clear contradictions. Instead, they linger at the edges of understanding, often explained through variations in environment, chemistry, or time. And yet there may be another layer to consider. If gravity influenced how sediments settled and how pressure shaped them, then even slight variations in that force could leave behind traces within the structure of the rock itself. Not as direct evidence, but as subtle differences in how layers formed and how materials compacted over time. The Earth, in this sense, becomes more than a container of history. It becomes a record of conditions, written not in words, but in patterns that require careful interpretation. The ground beneath our feet may still carry the imprint of a force that once behaved differently, not in a way that can be easily pointed to or measured directly, but in a way that can be felt through the quiet irregularities that appear when the record is examined closely. These irregularities are not errors. They are not flaws in the process. They are part of the story, details that may hold meaning if viewed from a slightly different perspective. The realization does not arrive all at once. It builds slowly, as each layer is considered, as each pattern is noticed. Fossils hinted at something unusual in the forms of life. Now the rocks themselves begin to suggest that the environment in which those forms existed may also have been shaped by conditions that are not entirely the same as those we experience today. And as these hints begin to align, a deeper question emerges, one that cannot be ignored for long. If both life and the ground it rests within carry subtle signs of something different, then why has this possibility remained so distant from common understanding? Why has it been so easy to overlook a force that is always present, yet rarely questioned even when the evidence may have been there all along, hidden in plain sight within the very structure of the Earth itself? There is a quiet structure beneath the way knowledge is built. It is not made of stone or sediment, but of ideas that feel stable enough to rely on. These ideas are called constants. They provide a foundation, something that does not shift while everything else is studied. Without them, understanding becomes difficult, uncertain, almost impossible to organize. And so they are accepted, not because they are proven in every moment, but because they allow everything else to make sense. Gravity is one of these constants. It is treated as something fixed, something that does not need to be questioned in the same way other variables are examined. When scientists study the past, they rely on this stability. They assume that the force pulling everything downward now is the same force that acted billions of years ago. This assumption is not careless. It is practical. It allows patterns to be recognized, models to be built, and conclusions to be drawn with confidence. But every assumption, no matter how useful, carries a boundary. It defines not only what can be understood, but also what is considered possible. When something is treated as unchanging, any variation becomes difficult to imagine, and even more difficult to detect. Evidence is interpreted through the lens of that assumption, shaped to fit within a framework that already feels complete. This is where the tension begins to form, not as a contradiction, but as a quiet gap between what is observed and how it is explained. Fossils that seem unusual are understood as evolutionary variations. Geological patterns that feel slightly out of place are attributed to environmental differences or unknown conditions. Each explanation fits within the existing model, reinforcing the sense that everything has been accounted for. And yet, the model itself rests on something that is rarely examined. If gravity is assumed to be constant, then its influence is never considered as a variable. It becomes invisible in a different way, not because it cannot be seen, but because it is not questioned. Its role is fixed in place, even though it is part of the system being studied. What if the reason we have not found certain answers is not because the evidence is missing, but because the questions have been limited from the beginning? What if the patterns that seem slightly inconsistent are not anomalies to be explained away, but signals pointing towards something that has been excluded from consideration? The idea does not challenge science itself. It reveals the way science operates, how it builds understanding step by step, relying on stable points to make sense of complex system. But it also shows that stability can come at a cost. When a foundation is never examined, it can quietly shape everything built upon it, guiding interpretation in ways that are not always visible. This does not mean that the assumption of constant gravity is wrong. It means that it may not be complete. It may describe the present accurately while leaving open the possibility that the past held conditions that were slightly different. Differences so small that they would not disrupt the overall picture, yet significant enough to influence the details. The realization settles slowly. The evidence has always been there, fossils, rocks, patterns in the earth itself. But the way that evidence has been viewed has been shaped by a framework that assumes certain things do not change. If that framework shifts, even slightly, then the same evidence begins to tell a different story. And with that shift, the question that once seemed unnecessary begins to take form, not as a challenge, but as an extension of understanding. If gravity is part of the system, if it depends on conditions that can change, then could it have changed as well? Could the force that feels so constant now have behaved differently in the distant past, in ways that are subtle, continuous, and difficult to trace? The thought does not arrive with certainty. It arrives with possibility, and that possibility opens the way forward, moving the story beyond assumptions and toward a deeper exploration of what gravity truly is, and whether it is as fixed as it has always seemed. To understand what may have changed, the story must pause and look more closely at what gravity truly is, not as a number written in a formula, not as a rule memorized and repeated, but as something deeper, something that exists only because other things exist. Gravity is often described as a force, something that pulls objects toward one another. This description feels simple, almost complete. But beneath that simplicity, there is a relationship that is more subtle than it first appears. Gravity does not exist on its own. It does not move through space like wind or light. It emerges from the presence of mass, from the way objects occupy space and influence the space around them. It depends on how much mass there is, how that mass is arranged, and how far apart different parts of that mass may be. Change any of these factors even slightly, and the nature of the pull begins to shift as well. This idea changes the way gravity is perceived. It is no longer something fixed, something that stands apart from the world it shapes. Instead, it becomes part of the world itself, connected to its structure, responding to its changes and reflecting its condition at any given moment. The planet is not simply held together by gravity. It creates gravity through what it is. The Earth, as it exists now, feels stable. Its mass is largely settled, its structure defined, its layers arranged in a way that has reached a kind of balance. Under these conditions, gravity feels constant. It behaves in ways that are predictable, measurable, and consistent across time. This consistency creates the impression of permanence, as if gravity itself is unchanging rather than the conditions that produce it. But when the Earth was younger, those conditions were not yet fixed. The planet was still forming its internal structure, still redistributing its mass, still adjusting the balance between its layers. In such a state, the relationship that produces gravity would not have been identical to what it is now. It would have followed the changes, adapting as the planet adapted, shifting quietly alongside it. The difference would not need to be large to matter. Gravity does not need to change dramatically to influence the world around it. Even a small variation, applied continuously, can shape how materials move, how structures form, and how systems evolve over time. The effect is not sudden. It is gradual, almost invisible, woven into every process without ever standing apart from it. This creates a shift in perspective that is both simple and profound. Gravity is not a fixed background against which events unfold. It is part of the system, a participant in the processes that shape the planet and everything on it. It responds to conditions, and in doing so it helps define those conditions in return. Gravity feels permanent, but what if it is only as stable as the world that creates it? What if its apparent constancy is not a property of the force itself, but a reflection of the current state of the planet? These questions do not disrupt what is known. They deepen it, revealing a layer that is often overlooked because it does not demand attention. As this idea settles, gravity begins to feel less like an unchanging rule and more like a quiet expression of balance. It reflects the structure of the Earth, the distribution of its mass, and the relationships between its parts. And if those elements have changed over time, then gravity, in its own subtle way, may have changed as well. This realization does not provide an answer. It opens a path. If gravity depends on conditions, then the next question becomes unavoidable, waiting just beneath the surface of understanding. What kinds of changes within the Earth or beyond it could actually influence this invisible force? And how might those changes have shaped the world in ways we are only beginning to consider? The story returns to the planet itself, not as a finished world, but as something that has never truly been still. The Earth, even now, continues to shift in ways that are difficult to notice within a single lifetime. Beneath the surface, layers move slowly, almost imperceptibly, carrying continents across vast distances. Deep within, heat circulates, driving processes that have been unfolding for billions of years. Nothing is fixed in the way it first appears. Stability, when it is felt, is only a moment within a much longer sequence of change in its earliest history. This movement was far more pronounced. The planet was not yet settled into the structure it holds today. Heavy materials sank toward the center, forming a dense core, while lighter materials rose, creating layers that would eventually define the surface. This separation did not occur evenly or instantly. It was a gradual process, one that continuously reshaped how mass was arranged within the planet. Each shift in that arrangement carried with it a quiet consequence. Gravity, as it has come to be understood, depends not only on the total mass of the Earth, but on how that mass is distributed. A planet with the same overall weight can produce slightly different gravitational effects depending on where its mass is concentrated. When the Earth's interior was still reorganizing, that concentration was not yet fixed. It changed as materials moved, as layers formed, as the planet adjusted itself from the inside out. There were also moments of disruption that added to this process. Massive impacts struck the early Earth, bringing new material, redistributing existing mass, and altering the balance that had begun to form. Each collision was not just an event at the surface. It was a rearrangement of the planet's internal structure, a shift in how weight was distributed across and within it. These changes would have influenced the gravitational field, not in ways that could be easily seen, but in ways that shaped how everything interacted with the planet as a whole. Even as the surface began to cool and oceans formed, the deeper processes did not stop. Tectonic activity continued to move large portions of the crust, lifting some regions while lowering others, redistributing mass across the surface over immense spans of time. Mountains rose, eroded, and rose again. Ocean basins deepened and shifted. Each of these changes contributed to the overall balance of the planet, altering the way mass was spread across its surface and interior. The important realization is not that these changes occurred, but how they connect to the force that holds everything together. Gravity is not only a result of how much mass exists, but how that mass is arranged. When the arrangement changes even slightly, the effect of gravity at different points on the surface can change as well. The differences may be small, almost impossible to detect without precise instruments, but they are present. They are part of the system, responding to the ongoing evolution of the planet. The Earth has never stopped changing, and neither has the force that holds it together. This idea does not arrive as a dramatic shift in understanding. It unfolds slowly as each piece connects to the next. The planet evolves, and the force it generates evolves with it, not as separate processes, but as parts of the same continuous system. This creates a quiet but striking insight. Gravity, often treated as a fixed constant, begins to feel more like a reflection of the planet's state at any given moment. As the Earth changes, gravity responds, adjusting in ways that are subtle yet persistent. The changes do not break the system, they shape it, guiding how materials move, how structures form, and how environments develop over time. And as this idea settles in, the implications begin to extend beyond geology. If the internal changes of the Earth could influence gravity, even in small ways, then those influences would not be limited to the movement of rock or the formation of landscapes. They would reach into every process that depends on that force, including the development of life itself. The story begins to shift again, moving from the structure of the planet to the systems that exist upon it. Because if gravity has been evolving alongside the Earth, then life has been evolving within that changing influence, adapting not only to its environment, but to the subtle shifts of a force that has never been entirely still. There is a tendency to look for change in dramatic moments. Sudden shifts, visible disruptions, events that leave clear marks behind. These are the kinds of changes that are easy to recognize, easy to measure, and easy to remember. But not all change happens this way. Some of it unfolds quietly, so slowly that no single moment reveals it. It does not announce itself, and because of that, it can shape outcomes far more deeply than anything sudden or obvious. The world is full of systems where small differences lead to lasting consequences. A slight variation in temperature can alter the course of climate over time. A small change in chemical balance can influence entire reactions, guiding them toward different results. In evolution, even the smallest advantage, repeated over countless generations, can transform the direction of life itself. These processes do not rely on large shifts. They depend on persistence, on conditions that act continuously, shaping outcomes step by step. Gravity fits into this pattern in a way that is easy to overlook. It is always present, always acting, always influencing the way things move and settle. Because it does not stop, even the smallest variation in its effect has the potential to accumulate over time. A slight difference does not need to be noticeable in a single moment to matter. It only needs to remain consistent, shaping every interaction, every movement, every formation across immense spans of time. This is where the scale of the story begins to expand. The early Earth existed for millions, then billions of years before life reached the forms we recognize today. Within that vast stretch of time, even a subtle shift in gravity could influence countless processes. The way particles settled in the oceans, the way sediments formed layers, the way structures developed within living organisms, all of it would be guided by this continuous force. A small difference applied without interruption becomes something far greater than it first appears. What if the smallest changes are the ones that reshape everything, simply because they never stop acting? The idea does not rely on dramatic variation. It depends on duration. The longer a condition remains in place, the more influence it has. Over time, it becomes part of the foundation, shaping outcomes in ways that are difficult to separate from the processes themselves. This leads to a shift in how gravity is understood. Its importance is not only in its strength, but in its consistency. It provides a steady influence that defines limits, guides movement, and shapes interactions. If that consistency were altered, even slightly, then everything built upon it would adjust in response. The changes would not appear as clear events. They would be woven into the structure of the world, becoming part of the way things naturally unfold. And because these changes are subtle, they are difficult to detect. There is no clear boundary, no moment where one condition ends and another begins. Instead, there is a gradual transition, one that blends into the background of the planet's history. By the time life becomes complex enough to leave clear records, the conditions that shaped its earliest stages may already feel distant, hidden within patterns that no longer appear unusual. The realization settles in slowly, bringing with it a sense of quiet inevitability. If gravity has been part of every process, and if even small variations can accumulate over time, then its influence may be far greater than it first seems. Not because it changed dramatically, but because it may have changed just enough to matter, continuously, without interruption. And with that understanding, the story begins to move forward again. Because if such subtle yet powerful changes were possible, then life would not have remained unchanged in response. It would have adapted, adjusted, and evolved within those shifting conditions, carrying with it traces of an influence that was always present, yet never directly seen. Life returns to the center of the story, not as something fixed, but as something that listens without knowing it is listening. It does not pause to consider the world around it. It does not question the conditions it exists within. Instead, it responds quietly and continuously, adjusting to whatever is present, becoming shaped by influences it cannot perceive. This is the nature of life in its earliest and simplest form, and it remains true even as life becomes more complex over time. From the beginning, survival has depended on the ability to adapt, not in sudden leaps, but in small, gradual shifts that accumulate across generations. A slight difference in how an organism grows, how it moves, how it uses energy, can determine whether it continues or fades away. These differences are not dramatic. They do not appear as transformations that can be easily seen. They emerge slowly, guided by the conditions that surround life at every moment. Gravity is one of those conditions. It does not act as a barrier or a challenge in the way that temperature or scarcity might. It is more constant than that, more subtle, woven into every interaction without drawing attention to itself. It influences how organisms hold their shape, how they move through water or across surfaces, how they distribute their weight and maintain balance. These influences are not separate from life. They are part of the environment life is responding to. If gravity was slightly different, life would not resist the change. It would not recognize it as something unusual. It would simply adjust. Structures would form in ways that match the conditions present. Movement would become more or less efficient depending on how the force interacts with the body. Over time, these adjustments would become part of what defines each organism, not as a response to change, but as a natural expression of the environment itself. This process is so gradual that it leaves no clear boundary. There is no moment where life suddenly becomes something new because gravity has shifted. Instead, there is a continuous flow where each generation carries forward the subtle influences of the one before it. The result is a pattern that feels stable, even though it is built from countless small adjustments that have occurred over immense spans of time. Life does not question the world it grows in. It simply becomes part of it. This quiet truth changes how evolution is understood. It is not only a response to visible challenges, but to every condition that shapes existence, including those that remain unseen. If gravity has been slightly different at any point, then life would have adapted to that difference without hesitation, incorporating it into the forms and functions that continue to evolve. This creates a realization that is easy to overlook. The evidence of such changes would not stand out as something separate. It would be embedded within life itself, hidden within the way organisms are structured, the way they interact with their environment, the way they have evolved over time. Because the changes were gradual, the adaptations would be gradual as well, blending seamlessly into what is considered normal. And because of that, the traces of these influences may be difficult to recognize. They would not appear as clear markers or sudden shifts. They would exist as patterns, subtle and continuous, shaping life in ways that are not immediately obvious. The question then begins to shift once more. If life adapts so seamlessly to the conditions around it, then how can those conditions be detected after they have changed? The story moves forward with this quiet uncertainty, leaving behind the idea of obvious evidence and moving towards something more subtle, more hidden, where the influence of an invisible force may still exist, waiting to be noticed in ways that are not yet fully understood. There is a certain kind of change that never announces itself. It does not arrive with a clear beginning or a visible end. It moves slowly, so gradually that it becomes part of the background, something that no longer feels like change at all. Over time, it settles into what is considered normal, shaping the world in ways that are no longer questioned. This is the kind of change that leaves behind a different kind of evidence, one that does not stand out, one that does not demand attention. When life adapts to its environment, it does so continuously. Each small adjustment becomes part of the baseline for what follows. There is no sharp division between what was and what is. Instead, there is a seamless progression where each stage flows into the next without interruption. If gravity shifted slowly even by a small amount, life would respond in the same way. The adaptation would be just as gradual, just as continuous, blending into the natural development of form and function. This creates a kind of invisibility. The evidence is not hidden because it is buried or lost. It is hidden because it is everywhere. It exists within the structures of living organisms, within the limits of their growth, within the way they interact with their surroundings. But because these features have always been observed as they are not seen as evidence of change. They are seen as the standard against which everything else is measured. What if the reason we cannot see the evidence is because it has always been there? The question does not suggest that something is missing. It suggests that something has been overlooked, not because it is difficult to find, but because it does not appear unusual. When patterns are consistent, they do not draw attention. They become part of the expected structure of the world. Only when something breaks that pattern does it stand out. But if the pattern itself was shaped by conditions that have since changed, then the evidence of those conditions remains quietly embedded within what is now considered normal. Consider the way organisms are structured, how their bodies support their weight, how they move, how they grow. These features are often explained through function and efficiency, through the demands of survival within a given environment. But those explanations assume that the underlying conditions have remained constant. If those conditions were slightly different in the past, then the structures that developed under them may carry traces of that difference, even if it is no longer immediately visible. The same is true for how organisms interact with their environment. The way nutrients are distributed, the way energy is used, the way systems balance themselves over time, all of it depends on forces that are always present, even when they are not directly considered. If those forces shifted, even slightly, the patterns that emerged would reflect that shift. But because the shift was gradual, the resulting patterns would not appear as evidence of change. They would appear as the natural state of things. This creates a paradox that is both simple and difficult to grasp. The evidence is not absent. It is present in every structure, every interaction, every pattern that has been observed and accepted. But it does not stand apart from those patterns. It is part of them, woven into the fabric of life in a way that makes it indistinguishable from what is expected. The absence of obvious evidence does not mean the absence of influence. It may mean that the influence has been so consistent, so integrated into the system, that it no longer appears as something separate. It becomes part of the definition of normal, even if that normal was shaped by conditions that no longer exist in exactly the same way. And as this idea begins to settle, it opens a new way of looking at the past, not as a series of clear events marked by obvious changes, but as a continuous flow where subtle influences accumulate and blend into the whole. If gravity played a role in that process, then its influence may still be present, hidden within patterns that have always been there, waiting to be seen from a different perspective. The story moves forward with this quiet realization. If the evidence blends into the background, then the question is no longer whether it exists, but whether it is only now beginning to be noticed, as the perspective shifts just enough to reveal what was always there, unnoticed, within the familiar world itself. The pieces do not come together all at once. They do not form a clear image that can be pointed to with certainty. Instead, they begin to align slowly, almost reluctantly, as if the story itself is revealing something that was never meant to be obvious. Fossils that seem slightly unusual, layers of rock that carry quiet inconsistencies, patterns in evolution that feel complete yet leave small questions, behind each on its own can be explained, understood, placed within the framework that has already been built. But when they are seen together, something begins to shift. It is not a contradiction of what is known. It is not a rejection of the explanations that already exist. It is something more subtle than that. It is the sense that beneath these explanations, there may be an additional layer, one that has not been fully considered because it does not stand out on its own, a layer that connects these small irregularities into something that feels less like coincidence and more like a pattern. What if we are only now beginning to see a pattern that has been shaping life from the very beginning? The question does not demand an immediate answer. It lingers, allowing the mind to move through what has already been seen. The delicate structures of early life, the way sediment settled into stone, the gradual adaptations that became part of evolution itself. All of it begins to feel connected by something that has never been directly observed, yet has always been present. Gravity does not leave behind clear evidence of its changes. It does not mark its influence in a way that can be easily separated from the processes it shapes, and yet if it were slightly different, even in ways that are difficult to measure, its effects would be woven into everything that followed, not as distinct signs but as subtle shifts in how systems formed, how structures developed, how environments supported life over time. This is where the perspective begins to change. The question is no longer whether gravity changed, because that question leads to a search for direct proof, for clear markers that may not exist. Instead, the question becomes something else entirely. What would the world look like if it had? Under that perspective, the details take on a different meaning. The unusual becomes expected. The inconsistencies become clues rather than problems to be resolved. The patterns that once seemed complete begin to reveal edges, places where something more may be present, just beyond what has been fully understood. The realization is quiet, almost gentle. It does not force a conclusion. It does not require certainty. It simply opens a way of seeing that allows the possibility to exist without disrupting the structure of what is already known. Gravity remains what it is, a force that holds everything together, but it is no longer confined to the idea of being perfectly unchanging across all of time. Instead, it becomes something that may have evolved alongside the planet, influencing life in ways that are subtle, continuous, and deeply integrated into the history that has already been studied. And with that shift, the story reaches a moment of clarity that feels less like an ending and more like a beginning. Because if these patterns are real, if they are not simply coincidences but part of a deeper influence, then they raise a new kind of question, not one about the past alone, but about the present. If something has been shaping the world in ways that are only now beginning to be noticed, then how can it be studied? How can it be tested, understood, or even confirmed within the limits of modern science? The path forward does not promise easy answers. It leads into a space where observation meets uncertainty, where the tools of the present are used to explore something that may have unfolded across a time far beyond direct measurement. And as that path begins to form, the story moves with it, leaving behind the quiet patterns of the past and turning toward the present, where the search begins again, this time with a different question guiding the way. The story moves forward into the present, where the world feels familiar, measured, and understood. The Earth appears stable, its surface mapped, its forces calculated with precision that would have seemed impossible in earlier times. Gravity, once an unseen influence, has become something that can be measured, predicted, and used to guide machines beyond the planet itself. And yet, even now, it remains invisible. It is never seen directly. It is known only through the way it shapes movement, the way it pulls, the way it holds everything in place. Modern science has learned to read this invisible force with remarkable accuracy. Instruments are designed to detect the slightest differences in how objects fall, how they accelerate, how they respond to the pull of the Earth. Satellites orbit the planet, tracking variations in gravitational strength by observing their own motion as they pass over different regions. These measurements are precise, sensitive enough to detect changes that are far too small to be noticed in everyday experience. At first, the results seem to confirm what has always been assumed. Gravity is consistent, predictable, stable across the surface of the planet. But as the data becomes more detailed, something more subtle begins to appear. The strength of gravity is not exactly the same everywhere. It varies slightly from one location to another. These variations are small, often measured in fractions that seem almost insignificant, and yet they are real, repeatable, and measurable. Mountains, for example, contain large amounts of mass, and this mass influences the gravitational pull in the regions around them. Oceans, with their depth and distribution, create their own variations. Beneath the surface, differences in density within the Earth's interior also affect how gravity is experienced above. These factors combine to create a gravitational field that is not perfectly uniform, but gently uneven, shaped by the structure of the planet itself. Even today, gravity is not exactly the same everywhere, and that changes everything. The realization is quiet, but it carries weight. The idea of gravity as a constant begins to shift, not dramatically, but enough to reveal something deeper. The force is consistent enough to feel stable, yet flexible enough to respond to the distribution of mass. It reflects the planet as it is, not as a perfect sphere, but as a complex system with variations that extend from the surface to the deepest layers within. These differences are not disruptive. They do not alter daily life in ways that can be easily noticed, but they prove something important. Gravity is not a single fixed value applied evenly across the entire Earth. It is a field, shaped by conditions responsive to the structure of the planet, changing in small ways that can now be observed. This creates a bridge between what is known and what has been suggested. If gravity varies slightly today, under conditions that are relatively stable, then it raises a question about the past. The early Earth was far less stable, its mass less evenly distributed, its internal structure still forming. If small variations exist now, could they have been more pronounced when the planet itself was still adjusting? The thought does not arrive as a conclusion. It emerges as a possibility, grounded in observation rather than speculation. The tools of modern science are already detecting the kind of variability that was once considered insignificant, and in doing so, they reveal that gravity is more dynamic than it first appears, even in the present. The story begins to shift once again, moving from observation to understanding, because if gravity varies even slightly, then the next question becomes unavoidable. How are these differences detected with such precision, and what do those measurements reveal about the deeper structure of the planet itself? The measurements themselves are only the beginning. Numbers appear, patterns emerge, and yet none of it explains itself. Gravity does not speak in clear images or visible shapes. It reveals itself through variation, through differences that must be translated into something meaningful. This is where observation becomes interpretation, where the invisible begins to take form through careful reading. Satellites circle the Earth in silence, moving along paths that are influenced by the pull beneath them. They do not see mountains or oceans in the way human eyes would. Instead, they feel them. As they pass over regions of greater mass, their motion changes slightly, almost imperceptibly. Over areas with less mass, the effect shifts again. These differences are recorded, mapped, and studied, not as direct images of the surface, but as patterns within the gravitational field itself. What begins to emerge is not a perfect sphere, but something far more complex. The Earth reveals itself as uneven, its mass distributed in ways that are not immediately obvious. Beneath the oceans, variations in density create subtle changes in gravitational strength. Beneath the continents, deep structures hidden within the crust and mantle leave their own imprint. Even the slow movement of tectonic plates contributes to this shifting pattern, altering the balance over time in ways that are only now becoming visible through measurement. The Earth is constantly whispering its secrets. We just learned how to listen. This quiet communication is not simple to understand. The signals do not arrive as clear statements. They require interpretation, a process of translating variation into meaning. Scientists study these patterns, comparing them, refining them, building models that attempt to explain what lies beneath the surface. Each variation becomes a clue pointing toward differences in structure, composition, and movement that cannot be seen directly. The idea begins to take shape that gravity is not only a force, but a kind of language. It carries information about the planet, about how its mass is arranged, about how it changes over time. This language is not spoken in words, but in patterns that must be carefully decoded. It is subtle, continuous, and always present, revealing details that would otherwise remain hidden. As these patterns are studied, a deeper realization begins to form. The variations observed today are the result of the planet as it exists now, with its current structure and distribution of mass. But that structure has not always been the same. The Earth has changed repeatedly over its history, reshaping itself through processes that have unfolded over billions of years. Each of those changes would have altered the gravitational field, creating patterns that were different from those observed today. This leads to a quiet but powerful connection. The tools used to measure gravity now are not only revealing the present, they are providing a way to imagine the past. If the current gravitational field reflects the current state of the planet, then past states would have produced their own patterns, shaped by the conditions that existed at that time. The scale of this idea begins to expand. The variations measured today are small, subtle, barely noticeable without advanced instruments. But in the past, when the Earth was less stable, when its mass was still redistributing, those variations may have been more pronounced. Not dramatically different, but enough to influence processes in ways that are now difficult to reconstruct directly. Modern tools, in this sense, become a bridge between what is known and what is no longer directly observable. They do not provide exact answers about the past, but they offer a glimpse into how gravity responds to change. By understanding how it behaves under current conditions, it becomes possible to imagine how it may have behaved under different ones. The story begins to shift again, moving from observation to reconstruction. Because if these variations can be detected and interpreted today, then perhaps they can also be used to explore something deeper. Not just how gravity behaves now, but how it may have behaved when the planet itself was still becoming what it is. And with that possibility, a new question begins to take shape. If modern science can detect these subtle differences, if it can read the hidden signals of the planet, then could it also begin to reconstruct the invisible patterns of the past, revealing how gravity once shaped the world in ways we are only now starting to understand? There is a limit to what can be observed directly. The past does not remain available to be measured in the same way as the present. It cannot be visited, cannot be tested in real time, cannot be seen as it once was. And yet it is not entirely gone. It leaves behind traces, patterns, structures that carry within them the memory of conditions that no longer exist. The challenge is not to find the past, but to understand it through what remains. This is where reconstruction begins, not as an attempt to recreate every detail, but as a way of building a picture from fragments. Scientists gather data from rocks, from fossils, from the structure of the planet itself. They examine how materials are arranged, how layers formed, how life developed and spread across different environments. Each piece of evidence offers a clue, not about gravity directly, but about the conditions in which gravity was acting at the time. Models are created to bring these clues together. They are not exact representations of the past. They are approximations, guided by what is known, shaped by what can be measured in the present. Simulations are used to explore how the Earth may have behaved under different conditions, how mass may have been distributed, how forces may have interacted over time. These models do not claim certainty. They offer possibilities, ways of understanding how the past might have unfolded. Gravity itself cannot be measured in the past. There is no instrument that can reach back and record its strength or distribution as it once was, but its effects can be inferred. The way sediments settled, the way structures formed, the way life adapted, these are all influenced by the conditions that existed at the time. By studying these patterns, it becomes possible to imagine how gravity may have been acting, even if it cannot be directly observed. This process is careful, deliberate, and always aware of its limits. Each model is tested against what is known, adjusted, refined, sometimes replaced. There is no single answer that can be confirmed beyond doubt. Instead, there is a range of possibilities, each one consistent with the evidence, each one offering a slightly different perspective on what may have been. We cannot travel back in time, but the Earth may still remember what we are trying to find. That memory is not clear or complete. It is fragmented, subtle, often difficult to interpret, but it is there, embedded in the structure of the planet and the patterns of life that have been preserved. The task is not to recover a perfect image of the past, but to understand how the present carries traces of what came before. As these reconstructions begin to take shape, a quiet tension emerges. The answers are not fully within reach, yet they are not entirely beyond understanding. Each model brings the possibility closer, revealing how even small changes in conditions could have influenced the development of the world. And among those conditions, gravity remains one of the most constant, yet potentially variable influences. If the models suggest even slight differences in how gravity behaved, then the implications begin to extend beyond the planet itself. They reach into the processes that shaped life, into the environments that supported it, into the structures that emerged over time. The effect would not be obvious. It would be woven into the fabric of everything that followed, shaping outcomes in ways that are difficult to separate from the processes themselves. This realization does not close the question, it deepens it. Because if gravity may have been different even slightly, then understanding that difference becomes more than an abstract idea. It becomes a way of seeing the past in a new light, of recognizing that the conditions we take for granted may not have always been the same. And as this possibility settles in, the story begins to move again, shifting from reconstruction to experience. Because beyond the models, beyond the data, there is another question waiting to be explored. What would it have felt like to exist in a world where gravity was not exactly what it is now, where every movement, every interaction, carried the influence of a force that was just slightly different from the one we know today? Imagine the world not as it is, but as it might have been, altered in a way so slight that nothing appears dramatically different at first glance. The sky would still stretch above, the oceans would still move, the ground would still feel solid beneath every step. And yet, something would feel different, not enough to alarm, not enough to be noticed immediately, but present in every motion, in every interaction between body and world. Gravity is not something we usually feel directly. It does not press itself into awareness. It is sensed through resistance, through weight, through the effort required to move. Every step taken, every object lifted, every drop of water falling carries its influence. It defines how quickly something returns to the ground, how firmly it is held in place, how much energy is needed to move against it. If gravity were slightly weaker, the change would not be dramatic. You would not float, you would not drift freely through the air. But movement would feel just a little easier. Steps would carry slightly further, objects would feel lighter in the hand, and the effort required to lift or move would be subtly reduced. The body would adjust without noticing, finding a new balance within the same familiar actions. If it were slightly stronger, the effect would be just as subtle, but in the opposite direction. Movements would feel heavier, more deliberate. The ground would seem to hold more firmly, requiring a bit more effort to rise from it. The difference would not stop motion, but it would shape it, guiding how energy is used, how balance is maintained, how the body interacts with the space around it. Water, too, would respond. The way it flows, the way it carries objects, the way it settles into layers would shift with even the smallest change. Currents might move differently. Resistance might feel slightly altered, and the balance between buoyancy and weight would adjust in ways that are difficult to isolate but impossible to avoid. Everything within the water would respond to this change, not as a disruption, but as a new condition to which it quietly adapts. What if the world once felt just slightly lighter, or slightly heavier, and no one was there to notice? The question does not suggest a dramatic transformation. It points to something more subtle, a difference that would not stand out because it would be the only reality that existed at that time. There would be no comparison, no reference point to reveal that anything was different. Life would grow within these conditions, shaped by them without awareness. Structures would develop in ways that match the balance of forces present. Movement would evolve to be efficient within that environment. Every adaptation would reflect the conditions that were constant at the time, even if those conditions are no longer the same. This is where the experience becomes more than imagination. It begins to connect back to the forms that have been preserved, to the patterns that have been observed. If the world once felt different in even the smallest way, then the life that evolved within it would carry that difference forward, not as something obvious, but as something embedded within its structure, its movement, its behavior. The realization unfolds slowly, not as a conclusion, but as a possibility that feels increasingly difficult to ignore. The difference does not need to be large to matter. It only needs to be present, shaping every interaction, every process, continuously over time. And as that possibility settles in, the story begins to move again, because if the experience of gravity shapes every movement, then it must also shape something deeper. It must influence how life grows, how it builds itself, how it takes form within the limits of the world it inhabits, leading into a deeper exploration of how those forms may have been defined by a force that was never quite the same as it is now. Life does not grow without limits. Every organism, no matter how simple or complex, exists within boundaries that define what is possible. These boundaries are not always visible, but they are always present. They shape how tall something can become, how wide it can spread, how much weight it can support without collapsing under itself. These limits are not chosen, they emerge from the conditions surrounding life, quietly guiding its form as it develops. Gravity is one of the forces that defines these limits. It acts continuously pulling downward, creating resistance that every structure must overcome or adapt to. In animals, this influence can be seen in the way bones support weight, in the balance between strength and flexibility. In plants, it appears in the way they grow upward, pushing against the pull that draws them toward the ground. Even in the smallest organisms, gravity plays a role in how structure is maintained, how materials are distributed, how balance is achieved. These effects are so familiar that they feel natural, almost inevitable. It is easy to assume that the limits of growth are fixed, that they represent something fundamental about life itself. But those limits are not independent. They are shaped by the forces acting upon life at every moment. Change the forces even slightly, and the limits begin to shift. If gravity were slightly weaker, the constraints on structure would ease. Organisms might be able to extend further, grow taller, or develop forms that are more delicate without losing stability. The balance between strength and size would adjust, allowing different shapes to emerge, not as extremes, but as natural outcomes within those conditions. The difference would not be dramatic, but it would be present in the details, in the way structures hold together and function over time. If gravity were slightly stronger, the opposite would occur. Structures would need to be more compact, more resistant to collapse. Growth might favor forms that distribute weight more efficiently, that remain closer to the ground, that rely on stability rather than extension. Again, the change would not be sudden or extreme. It would be subtle, shaping the direction of growth in ways that become part of what is considered normal within that environment. The limits of life are not fixed. They are shaped by the forces around it. This idea begins to reshape how early life forms are viewed. Some structures that seem unusual today may not have been unusual at all under different conditions. Forms that appear too delicate, too extended, or too inefficient by modern standards may have been perfectly stable within a world where the balance of forces was slightly different. What seems like an anomaly may simply be a reflection of a different set of limits. This does not require a complete rethinking of biology. It does not suggest that everything is misunderstood. It introduces a shift in perspective, one that allows for the possibility that the conditions shaping life were not always identical to those we experience now. The principles remain the same, but the boundaries within which they operate may have been different. The realization is quiet, but it carries weight. Life adapts not only to visible conditions, but to every force that acts upon it, even those that remain unseen. If gravity played a role in shaping those limits, then its influence is embedded within the forms that have been preserved, within the patterns that have been observed. And as this perspective settles in, it begins to extend beyond individual organisms. Because life does not exist in isolation, it exists within systems, within environments where multiple forms interact, compete, and balance each other. If the limits of growth and structure are influenced by gravity, then those influences would not stop at the level of a single organism. They would shape entire ecosystems, guiding how life organizes itself within a world defined by forces that are always present, yet rarely considered. Life does not exist alone. It gathers, overlaps, and forms systems where each part depends on the others. What begins as a single organism becomes a network, and that network becomes an ecosystem. Within it, everything is connected. Water carries nutrients, organisms compete and cooperate. Energy moves through layers of life in patterns that feel stable, yet are constantly adjusting beneath the surface. Gravity is present in all of this, not as a visible force, but as a quiet guide shaping how these connections unfold. It influences how water moves, how particles settle, how nutrients are distributed through the environment. It defines the direction of flow, the balance between rising and sinking, the way materials circulate over time. These processes form the foundation of every ecosystem, even when they are not directly observed. In the early world, these systems were still forming. The oceans were not yet as stable as they are now. The distribution of land and water was different, and the balance between various elements was still being established. Within this shifting environment, Ecosystems began to emerge, shaped by conditions that were not entirely fixed. Life adapted to these conditions, forming relationships that reflected the world as it existed at that time. If gravity were slightly different, even in subtle ways, its influence would extend through the entire system. The movement of water would change, altering how nutrients are carried from one place to another. Areas that once supported certain forms of life might shift, becoming more or less suitable depending on how resources are distributed. The balance between organisms would adjust, not through sudden disruption, but through gradual changes that influence survival over time. These effects would not appear as clear transformations. They would unfold slowly, shaping the ecosystem in ways that become part of its natural state. A small difference in how particles settle could influence where nutrients accumulate. That, in turn, could affect where organisms thrive, which species become more dominant, and how energy moves through the system. Each change builds upon the next, creating a network of interactions that reflects the conditions under which it developed. An entire world can change, not through chaos, but through the quiet shift of a single force. This idea brings the story to a broader perspective. Gravity is no longer seen only as something that shapes individual movement or structure. It becomes something that influences entire systems, guiding how life organizes itself within the environment. Its presence is constant, but its effects are distributed, touching every part of the ecosystem without ever becoming the focus of attention. The interconnectedness of these systems means that no change exists in isolation. A subtle shift in one area ripples outward, influencing processes that seem unrelated at first. The flow of water affects the availability of nutrients. The availability of nutrients affects the growth of organisms. The growth of organisms affects the balance of the ecosystem as a whole. Through this chain of interactions, even the smallest difference can extend across the entire system. The realization is quiet, but it deepens the sense of scale. Gravity, often overlooked because it is always present, begins to feel like an architect working in the background, shaping the structure of ecosystems over time. Not through forceful intervention, but through steady influence, guiding how everything fits together. And as this vision of the past takes shape, it begins to connect to something more immediate. Because if gravity played such a role in shaping early ecosystems, then its influence has not stopped. The same force continues to act, guiding the systems that exist today. The story turns gently toward the present, carrying with it a question that feels both simple and profound. If gravity has shaped the world in such subtle yet far-reaching ways, then how stable is it now? Is it truly as constant as it appears? Or is it still part of a process that continues quietly beyond what we can easily perceive? The present feels solid, the ground holds, the oceans follow their rhythms, and the pull that keeps everything in place behaves as it always has within living memory. Gravity appears unchanged, reliable, something that does not need to be questioned, because it has never given a reason to doubt it. This sense of permanence is not something consciously chosen. It emerges from experience, from the consistency that surrounds every moment of daily life. Human perception is shaped by time, but only within a narrow window. A lifetime, even stretched across decades, is brief when compared to the age of the planet. Within that span, anything that does not visibly change begins to feel fixed. Patterns repeat, expectations form, and stability becomes the default assumption. Gravity, always present and always consistent in this time frame, becomes one of the clearest examples of something that seems permanent. But permanence in this sense is not absolute. It is relative to the scale at which it is observed. What feels permanent may only be stable for as long as we are here to observe it. This idea begins to unfold slowly, almost imperceptibly. The Earth itself provides countless examples of change that occur beyond immediate perception. Continents move, but so slowly that their motion cannot be seen without measurement. Mountains rise and erode, but the process stretches across spans of time, far beyond a single human life. Oceans shift, climates evolve, and internal structures rearrange themselves, all without drawing attention to the gradual nature of their transformation. These changes do not feel like change when experienced moment to moment. They feel like stability, like a world that has always been as it is. Only when viewed across vast stretches of time do they reveal their movement, showing that what appears fixed is often part of a much longer process. Gravity, when placed within this context, begins to feel different. It is still consistent within the present, still measurable, still predictable, but its apparent permanence may be tied to the same limitation of perspective. If the conditions that influence gravity have changed in the past, then its stability may not be an unchanging property, but a reflection of the current state of the planet. This does not suggest that gravity is fluctuating in ways that can be easily noticed. It does not imply sudden or unpredictable shifts. Instead, it introduces the possibility that over immense spans of time, even the most stable forces may evolve alongside the systems that produce them. The changes would be gradual, continuous, and subtle enough to blend into the background of the planet's history. The realization does not disrupt the sense of stability that exists in the present. It expands it, placing it within a larger framework where stability is not a fixed condition, but a phase within an ongoing process. What feels constant now may have been slightly different in the past, and may continue to change in ways that are too slow to be noticed directly. This shift in perspective creates a quiet tension. It does not replace certainty with doubt. It replaces simplicity with depth, revealing that even the most familiar aspects of the world may carry layers that extend beyond immediate perception. Gravity remains what it is, but its role becomes more dynamic, more connected to the evolution of the planet itself. And as this idea settles, it leads naturally to another question, one that feels both inevitable and difficult to answer. If stability is relative, if what appears constant is shaped by the limits of observation, then could gravity still be changing, even now, in ways that are too subtle to detect without looking far beyond the scale of a single lifetime? There are movements within the world that never reveal themselves in a single moment. They do not arrive with a beginning that can be pointed to, nor do they end in a way that can be clearly marked. Instead, they unfold across spans of time so vast that no single observer can witness their full course. These are the changes that shape the planet most deeply, not through sudden events, but through persistence. The continents shift, carrying entire landscapes across the surface of the Earth. This motion is continuous, yet it is measured in distances so small over a human lifetime that it feels as though nothing is moving at all. The climate adjusts, gradually altering patterns of temperature, wind and water over centuries and beyond. Even the rotation of the planet, something that feels perfectly steady, changes slightly over time, slowing in ways that can only be detected through careful measurement. These processes share a common quality. They are slow, subtle, and constant. They do not need to be dramatic to matter. Their power comes from their persistence, from the way they continue without interruption, shaping outcomes over immense periods of time. The most powerful changes are often the ones no one lives long enough to see. This idea begins to extend towards something less obvious. Gravity, like these processes, is always present. It acts continuously, influencing every interaction, every movement, every structure that forms within the system of the Earth. It feels unchanging because it does not vary in ways that are noticeable within a short span of time. But when placed alongside other processes that evolve slowly, the possibility begins to emerge that it too may be part of a longer transformation. The Earth is not static. Its internal structure continues to adjust, its mass redistributes, its balance shifts in ways that are difficult to perceive directly. As these changes occur, they influence the conditions that produce gravity. The effect may be small, almost imperceptible, but it does not need to be large to matter. Like the movement of continents or the gradual change of climate, it only needs to continue. This creates a subtle shift in understanding. The world that is experienced in the present is not a fixed state. It is a moment within a continuous process shaped by forces that have been acting long before and will continue long after. Stability, in this sense, is not the absence of change. It is the appearance of balance within a system that is always evolving. Gravity, when viewed in this way, becomes part of that evolution, not as something that fluctuates wildly, but as something that responds to the ongoing changes of the planet. Its variations may be so small that they blend into the background, becoming indistinguishable from the constant it appears to be. And yet, over vast stretches of time, those small variations could accumulate, shaping the conditions under which life develops and environments form. There is a quiet unease in this realization, not because it suggests instability, but because it reveals depth. The world is more dynamic than it first appears, more connected, more responsive to processes that extend beyond immediate perception. What feels permanent is part of a flow. What feels fixed is part of a sequence that continues without pause. This does not change the way the present is experienced. Gravity still holds, the ground still feels solid. The world remains stable within the scale of daily life, but beneath that stability, there is a sense of motion, of ongoing transformation that is too slow to be directly observed. And as this awareness begins to settle, it leads to a final question that feels both distant and immediate. If change is ongoing, if even the most constant forces may be part of a longer evolution, then what does that mean for how the past is understood, and for how the future might unfold within a system that has never truly stopped changing? The story begins to gather itself, not by closing, but by revealing how each part has always been connected. From the earliest formation of the planet to the quiet stability of the present, a single force has remained present through every stage. It has not drawn attention to itself, it has not needed to, and yet it has been there in every moment, shaping the path that everything else has taken. Gravity does not belong to one part of the story. It is not limited to the movement of planets or the fall of objects. It is woven into the formation of the Earth, guiding how matter came together in the first place. It influenced how the planet settled, how its layers formed, how its surface became capable of supporting oceans and atmosphere. Without it, there would be no structure to hold anything in place. As life began to emerge, that same force continued to act, quietly defining the limits within which life could grow. It shaped how organisms moved, how they built their structures, how they interacted with their surroundings. It influenced the flow of water, the distribution of nutrients, the balance of ecosystems that slowly developed over time. At no point did it step forward as something separate. It remained part of the system, constant enough to feel invisible, yet essential to everything that followed. Now, in the present, it continues in the same way. Every movement, every interaction, every moment of balance depends on it. The body adjusts to it without thought. The world responds to it without pause. It is so familiar that it disappears into the background, becoming something that is rarely considered, rarely questioned. And yet, when seen across the full span of time, its role begins to feel different. It is not simply a constant that remains unchanged while everything else evolves. It is part of that evolution, connected to the conditions that shape it, responding in ways that are subtle but continuous. The same force that holds everything together may also carry within it the history of how the planet has changed. The force we feel every moment may hold the deepest story we have yet to fully understand. This realization does not arrive as a conclusion. It settles slowly, bringing with it a sense of quiet awe. Gravity is no longer just a background presence. It becomes a thread that runs through everything, linking the formation of the Earth to the emergence of life, connecting the distant past to the present in a way that feels both simple and profound. It is not something that needs to be dramatic to be important. Its influence is steady, consistent, and far-reaching. It shapes the boundaries within which everything exists, guiding processes that unfold over timescales far beyond immediate perception. And because it is always present, its role is often overlooked, its significance hidden within the familiarity of everyday experience. Seeing it differently does not change how it behaves. It changes how it is understood. It becomes part of a larger system, one that evolves over time, where even the most stable forces may reflect the ongoing changes of the world they shape. This perspective does not replace what is known. It expands it, adding depth to something that has always been there. The story does not end with an answer. It remains open, inviting reflection rather than resolution. Gravity continues to act just as it always has, holding everything in place while the world continues to change around it. But now it carries a different meaning, one that connects every part of the story into a single continuous thread. And as this understanding settles, the path forward begins to take shape. Because if gravity is not just a constant but part of an evolving system, then its story is not finished. It extends beyond the present, reaching into questions that have yet to be fully explored, guiding the narrative toward what lies ahead, where the future of life and the deeper structure of the universe begin to unfold together. The story of life is often told as a steady unfolding. Simple beginnings give rise to complexity, guided by time, environment, and the quiet persistence of adaptation. It is a narrative that feels complete, supported by fossils, genetic evidence, and the patterns that connect all living things. Within this story, certain assumptions remain so stable that they are rarely noticed. Gravity is one of them, present in every moment, yet almost never questioned as part of the process itself. This assumption does not weaken the story. It allows it to exist with clarity and structure. By treating gravity as constant, it becomes possible to focus on the variables that appear to change more visibly: climate, chemistry, competition, survival. These elements shape the path of evolution in ways that can be observed and studied, creating a framework that feels both logical and complete. But what happens when something so fundamental is reconsidered? Not as an error, but as an overlooked dimension. What if the story of life is not wrong, but missing a chapter no one thought to write? The idea does not replace what is known. It expands it, adding a layer that has always been present but rarely explored. If gravity has shifted even slightly over the vast span of Earth's history, then the conditions under which life evolved may not have been as fixed as they appear from the present perspective. The environments that shaped early organisms would still exist, but they would carry an additional influence, one that quietly guided how life responded and adapted. This creates a subtle shift in how evolution is imagined. It is no longer only a response to visible conditions, but to a system that includes forces that are constant in presence, yet potentially variable in effect. The path of life remains grounded in biology, in chemistry, in the interaction between organisms and their surroundings. But those surroundings are now understood as part of a larger structure, one that includes the distribution of mass, the balance of forces, and the conditions that define how everything interacts. The timeline does not need to change dramatically for this idea to matter. The sequence of events, the emergence of different forms of life, the gradual increase in complexity, all of it can remain intact. What shifts is the context in which these events occurred. The world becomes slightly more dynamic, slightly less fixed, shaped by influences that extend beyond what is immediately visible. This perspective introduces a quiet tension. It does not challenge the evidence that has been gathered. It challenges the lens through which the evidence is interpreted. If gravity has always been assumed to be constant, then its role in shaping life has been considered stable as well. But if that assumption is incomplete, then the interpretation of patterns may also be incomplete. Not because the data is wrong, but because it has been viewed within a limited framework. The realization unfolds gently, allowing the familiar story to remain while opening it to new possibilities. Early life becomes part of a system that was still adjusting, responding not only to chemical and environmental conditions, but to the subtle influence of a force that may not have been entirely stable. The forms that emerged, the structures that developed, the pathways that were taken, all of them may carry traces of this influence, even if those traces are difficult to isolate. This does not create confusion. It creates depth. The story of life becomes richer, more connected to the broader processes of the planet. It becomes a story not only of living systems, but of the conditions that made those systems possible, conditions that may have been evolving alongside life itself. And as this expanded view begins to settle, the implications start to reach beyond the Earth. Because if life here may have been shaped by subtle variations in gravity, then the question begins to extend outward. What does this mean for life in other places, under different conditions, where the forces that define existence may not match those of Earth at all? The story moves forward with this question, leaving behind the idea of a single fixed narrative and stepping into a wider perspective where life is understood as part of a universe filled with variation, waiting to be explored. The story widens, moving beyond the boundaries of Earth and into a universe filled with worlds that exist under different conditions. Each planet carries its own balance of mass and distance, its own relationship with the space around it, and from that relationship emerges a different experience of gravity. It is not a single universal feeling. It changes from place to place, shaping how each world holds itself together. On some planets, gravity is stronger, pulling everything closer, compressing structures, limiting how tall or expansive anything can become. On others, it is weaker, allowing movement to feel lighter, enabling forms that might seem fragile by Earth's standards to exist with stability. These differences are not abstract. They define what is possible. They influence how surfaces form, how atmospheres behave, how liquids move, and how any form of life, if it exists, would grow and adapt. Life on other worlds would follow different rules. But what if Earth once did too? The question does not feel as distant as it first appears. It begins in the imagination of alien landscapes, but it quickly turns back towards something more familiar. Earth, often treated as a stable reference point, becomes part of the same spectrum. If gravity varies across the universe, then it is not a fixed experience tied to a single condition. It is a result of circumstances, of mass, of structure, of relationships that can change. This realization creates a bridge between the known and the possible. Other worlds are not simply different because they are far away. They are different because the forces shaping them are different. And if those forces define what life can become, then life itself is not a single pattern repeated across the universe. It is a response, a reflection of the conditions in which it emerges. On a planet with stronger gravity, life might develop in ways that prioritize stability and compactness. Structures would need to support greater weight, movement would require more energy, and the balance between form and function would shift accordingly. On a world with weaker gravity, the opposite might occur. Organisms could extend further, grow taller, move with less resistance, creating forms that would feel unfamiliar when compared to those on Earth. These ideas are often used to imagine life beyond our planet. They belong to the realm of speculation, of possibility, of what might exist in places that cannot yet be directly explored. But as the perspective begins to shift, something unexpected happens. The same logic that applies to distant worlds begins to turn inward. If gravity is not universal in its experience, then Earth itself becomes part of that variation. It is not exempt from change simply because it is familiar. The conditions that define it now are the result of a long history, one that includes formation, transformation, and continuous adjustment. If those processes have influenced the structure of the planet, then they have also influenced the force that emerges from that structure. This leads to a quiet but powerful realization. The Earth of the past may not have felt exactly like the Earth of the present, not in ways that are dramatic or easily imagined, but in ways that are subtle, continuous, and deeply connected to the changes the planet has undergone. In that sense, the early Earth may have been, in its own way, slightly alien compared to what exists now. The idea does not remove the familiarity of the world. It deepens it. It suggests that the planet is part of the same dynamic system as every other world, shaped by forces that evolve over time. Gravity, in this context, becomes something that links all planets together while still allowing each one to be unique. As this perspective settles, the story begins to take on a broader meaning. The question is no longer limited to what happened in the past. It extends into how life might exist elsewhere, how it might respond to conditions that are different from those on Earth, and how those differences could shape entirely new forms of existence. And with that expansion, a deeper understanding begins to form. If gravity shapes life everywhere, if it defines the limits and possibilities of every world, then understanding its role becomes more than a question about the past. It becomes a way of exploring what may come next, both on Earth and beyond, where the same invisible force continues to shape possibilities that are only beginning to be imagined. The past does not remain behind. It continues quietly within the present, shaping what will come next. The story of the Earth is not divided into separate chapters that begin and end. It is a continuous movement where every stage carries forward the conditions of the one before it. What has already happened does not disappear. It becomes part of the foundation upon which the future unfolds. In this way, understanding the past is not only about looking backward, it is about recognizing patterns that continue to act, forces that remain present, influences that do not stop when a particular moment has passed. Gravity is one of these forces. It has been there from the beginning, shaping the formation of the planet, guiding the emergence of life, and continuing to act in every moment that follows. If gravity has been part of a dynamic system, responding to changes in the planet's structure and conditions, then it is not something that belongs only to the past. It remains connected to the processes that are still unfolding. The Earth has not stopped changing. Its interior continues to move, its surface continues to shift, and its balance continues to adjust in ways that are difficult to perceive directly. The future may already be written in the same quiet forces that shape the past. This idea does not suggest that the future is fixed or predetermined. It suggests that the same influences that have shaped the world up to this point will continue to act, guiding what comes next. Gravity, as part of this system, remains constant in presence, yet connected to conditions that evolve over time. Its role does not end. It continues, shaping the boundaries within which change occurs. The scale of this continuity is difficult to fully grasp. The changes that may influence gravity are slow, unfolding over millions or billions of years. They do not appear within a single lifetime. They do not announce themselves as events. Instead, they blend into the ongoing evolution of the planet, becoming part of a process that feels stable even as it continues to shift. This creates a sense of quiet reflection. The present is not separate from the past, and the future is not separate from the present. They are all part of the same flow, connected by forces that act continuously across time. Gravity becomes a thread that runs through this entire sequence, linking the earliest stages of the Earth to what it will become in the distant future. The implications of this idea are subtle but far-reaching. If gravity has influenced the development of life in the past, then it will continue to influence life as it evolves. The conditions that shape organisms, ecosystems, and environments are not fixed. They are part of a system that continues to change, even if those changes are too slow to be noticed directly. This does not create uncertainty in a negative sense. It creates depth, a recognition that the world is part of something larger, something that extends beyond immediate perception. The forces that shape existence are not static. They are part of an ongoing process, one that connects everything across time. As this understanding begins to settle, the story moves toward a final realization. The past, the present, and the future are not separate ideas. They are different expressions of the same system, shaped by the same forces, connected through a continuity that is always present. And as these connections come into focus, the narrative begins to draw together everything that's been explored. The invisible force that has remained in the background is no longer just a constant. It becomes something more, something that carries meaning across time, leading the story into its final chapter, where its role is seen in a new and deeper light. The story returns to where it began, not with a new discovery, but with a deeper way of seeing what has always been there. The Earth, in all its complexity, in all its history of change, has never existed without a force holding it together. From the earliest moments of its formation to the present day, something invisible has guided every process, shaping outcomes without ever appearing at the center of attention. Gravity does not arrive as an event. It does not leave behind dramatic traces that mark its influence in obvious ways. It works quietly, continuously, forming the structure of the planet, guiding how matter gathers, how layers settle, how balance is achieved. Without it, there would be no surface to stand on, no oceans to flow, no atmosphere to hold. Everything that exists depends on its presence, even as that presence remains unnoticed. The force that shaped everything never needed to be seen. This realization does not come as a sudden revelation. It unfolds slowly, connecting each part of the story that has been explored. The formation of the Earth, once imagined as a chaotic process of collisions and heat, reveals an underlying order shaped by gravity's steady influence. The shifting of mass, the creation of layers, the gradual stabilization of the planet, all of it guided by a force that does not act with intention, yet defines what is possible. As life emerged, that same force continued to act, not as something separate, but as part of the conditions that made life possible. It shaped how organisms grew, how they moved, how they interacted with their environment. It influenced ecosystems, guided the flow of water, and defined the limits within which life could develop. Its role was never isolated. It was always integrated, woven into every process without standing apart from it. Even the subtle variations that may have existed, the small shifts in conditions that unfolded over immense spans of time, become part of this larger picture. If gravity has changed even slightly, then it has done so in a way that is consistent with its nature, gradual, continuous, and deeply connected to the evolution of the planet itself. Its influence does not need to be dramatic to be meaningful. It only needs to be present, shaping outcomes in ways that are felt but rarely recognized. There is a quiet sense of awe in this understanding. Something so familiar, so constant, begins to feel different when seen in this light. Gravity is no longer just a background condition, something assumed and overlooked. It becomes an active participant in the story of the Earth, guiding its development in ways that extend from the formation of the planet to the emergence of life and beyond. And yet it remains silent. It does not reveal itself directly. It does not demand attention. Its presence is known only through its effects, through the way everything holds together, through the patterns that emerge over time. It is both essential and invisible, shaping the world without ever stepping into view. This is where the story finds its balance. Not in a final answer, not in a conclusion that resolves every question, but in a deeper appreciation of what has been there all along. The most powerful forces are often the least noticed, not because they are hidden, but because they are constant, integrated so completely into the fabric of the world that they become part of what is taken for granted. As this realization settles, the narrative begins to move gently toward its final reflection, because understanding gravity as this quiet architect is only part of the story. The deeper question remains, waiting just beyond the surface of thought. What does it mean to live within a force that shapes everything, yet remains almost entirely unseen? The story narrows, not by becoming smaller, but by becoming closer. It moves from the scale of planets and deep time into the quiet space of the present moment, where everything feels immediate, familiar, and unchanged. The ground beneath your feet feels steady. The air rests gently around you. Every object remains where it is placed. Every movement follows a pattern that seems natural, expected, almost effortless. And yet none of this exists on its own. You have never escaped this force, not for a single moment of your life. From the first breath to the last, gravity has been there, shaping every action without ever asking to be noticed. It defines how the body stands, how it moves, how it rests. It determines the effort required to lift an arm, to take a step, to simply remain upright. These sensations are so constant that they fade into the background, becoming part of what it feels like to exist. The same is true for everything around you. Buildings rise because they are designed to stand against the pull that holds them down. Water flows, settles, and gathers because of the balance gravity creates. The atmosphere itself is held close to the planet, forming the thin layer that allows life to continue. Every structure, every system, every moment is shaped by a force that is never directly seen. And because it is always present, it becomes invisible in a different way. Not hidden, but overlooked. It does not demand attention because it does not change in ways that can be easily felt. It remains constant within the scale of daily life, creating the illusion that it is something separate from experience, something that exists in the background rather than as part of every interaction. But the story has shown something more. Gravity is not just a constant. It is part of a system that has evolved, that has shaped the planet and life upon it in ways that are subtle, continuous, and deeply connected to everything that exists. The same force that guided the formation of the Earth, that influenced the earliest forms of life, is still acting now, shaping the present moment in ways that are easy to ignore. This creates a shift in perspective that feels both simple and profound. The world is no longer something that exists around you, separate from the forces that shape it. You are part of that system, moving within it, responding to it, shaped by it in ways that do not require awareness to be real. Every action is part of the same continuous story that began long before any observer existed. There is a quiet realization in this, one that does not arrive with urgency, but with reflection. The most constant aspects of existence are often the least examined. They are accepted, assumed, rarely questioned, and yet they hold the deepest influence, guiding everything without ever stepping into focus. Perhaps the greatest mystery is not that gravity might have changed, but that it has always been there, shaping everything, without ever truly being noticed. This thought lingers, not as a conclusion, but as an invitation. To see the familiar differently, to recognize that what feels stable and unchanging may carry layers of meaning that extend far beyond immediate perception. The ground beneath your feet, the weight of your body, the stillness of objects around you, all of it becomes part of something larger, something that connects the present moment to the vast history of the planet. And as the story turns inward, it begins to settle into its final reflection. Because everything that's been explored, from the earliest formation of the Earth to the quiet patterns of the present, leads to a single realization that remains just beneath the surface, waiting to be fully understood. The story does not arrive at an ending. It softens, it settles, and then it continues, just as it always has. The Earth turns without pause, carrying oceans, land, and life through the same quiet motion that has defined every moment of its existence. Nothing announces this movement. Nothing marks where one phase ends and another begins. It simply goes on. Gravity remains. It does not change in ways that can be easily seen. It does not reveal itself as something separate from the world it shapes. It continues to act just as it has from the beginning, holding everything in place, guiding every interaction, forming the foundation upon which all else exists. Its presence is constant, yet its nature remains something that can still be questioned, still be explored, still be understood more deeply. The story never ended, it simply became too quiet to notice. There is something almost imperceptible in this realization. The same force that may have shaped the earliest conditions of the planet continues now, unchanged in presence, yet part of a system that has never stopped evolving. The Earth beneath it has shifted, its structure has adjusted, its balance has transformed across time. Life has emerged, adapted, and grown in complexity. And through all of this, gravity has remained, not as a passive backdrop, but as a continuous influence woven into every process. Whether it has changed even slightly remains a question that does not demand a final answer. It does not need to be resolved to carry meaning. The possibility itself becomes part of the story, opening a space where understanding can expand without closing into certainty. It invites reflection rather than conclusion, curiosity rather than finality. The silence that surrounds this idea is not emptiness. It is continuity. It is the absence of interruption, the steady presence of something that does not need to draw attention to shape everything it touches. The world feels complete, stable, familiar, and yet beneath that familiarity, everything continues. The continents move slowly and without sound. The oceans shift, carrying energy across the surface of the planet. Life responds, adjusting to conditions that are always in motion, even when that motion cannot be seen. The systems that define existence do not stop. They do not reach a final state. They remain in balance only because they are always changing. And within all of this, gravity continues to act. It does not arrive or depart. It does not begin or end. It remains, shaping the structure of the world in ways that are both obvious and hidden. It defines the limits of movement, the boundaries of growth, the conditions within which life exists. It is part of every moment, even when it is not recognized. The story, then, is not something that can be finished. It extends beyond the present, beyond the limits of observation, into a future that will unfold in the same quiet way as the past. The questions that remain are not meant to be closed. They are meant to continue, carried forward as part of a deeper awareness of the world and the forces that shape it. There is a calm in this, a sense that nothing needs to be resolved for the story to have meaning. The Earth continues. Gravity continues. Life continues. And in that continuation, the most important forces remain the ones that are never seen, never announced, yet always present, shaping everything without ever asking to be noticed.